I mean, I'm still on number 1 anyway. Dad, God, I can't believe I forgot. Come on, come on, come on. There we go. I have a feeling my computer's going to crash. It's going super slow. Hopefully not. Go. Oh. Ah. Is it shared? All right. Okay, so it's shared now, and we're recording. All right. So here I'm going to go back over them. There we go. All right. So back to the first one again, real quick. So what does the answer to an equation mean? The answer to an equation means that if we substitute that number back in for the variable, so in this case, x is the variable, 4x subtract 12 equals 24 was the original equation. If I substitute the number back in, the answer back in, if it makes the left side equal the right side, that's the answer. I just tried 3 right here. I just plugged 3 in because I thought that was the answer, just looking at it. And 3 didn't work. 4 times 3 was 12. 12 subtract 12 is 0. 0 does not equal 24. So the left side did not equal the right side. So I need to now solve it out. I need to stop taking shortcuts. I need to actually solve it out so I make sure I get the correct answer. So my first step is I start with the constant that's on the same side as the variable. And I do the opposite, either add or subtract. In this case, the opposite is adding. So that's going to cancel out. Well, if I do it on one side, I got to do it on the other side. I still have the 4x, didn't do anything with that. Now I'm on the last step. Last step is oftentimes division because I have 4 times x right here. 4x is 4 times x. Well, I need to do the opposite math again. I don't know why. I mean, I know why I divided by 9. I'm ahead of myself. So I divide by 4. Whatever number is with the variable is what we divide by because we're doing the opposite math. Opposite of multiplying by 4 is dividing by 4, but if I do it on the left, got to do it on the right. So I get x is 9. Now, if that is truly the answer, when I plug it back into the original equation, the left side better equal the right side. So 4 times 9 is 36. 36 subtract 12 is 24. So the left side equals the right side. That's what an answer is. You plug it in, the left side equals the right side. What's it mean to solve for a variable? I think most people, I want to say, got that one right. That means you're getting the variable all by itself. Just like down here, when we solved for x, we got x all by itself. We got rid of the 12, and then we got rid of the 4. So all we were left with on the left was x. We got the variable by itself. I'm going to do something I did in the other class. I wasn't going to do it in this class because I got off track last time. But I'm going to do it because I kind of liked it. This is mainly, this second one is mainly for the lesson coming up in the future, which I'm going to kind of introduce right now. You're going to deal with equations and you're going to have to solve for a variable, but there's going to be no numbers in it. You're going to solve for something and just get a bunch of letters on the other side, which freaks people out. But it's the same exact steps that we go through when we have numbers. Who knows what the formula for distance is? What's the formula for distance? What's that? That's a type of distance, but how do you calculate how far you go? There's 2 things that go into it. Think about what goes into how far you go. Just say it out loud. Who cares if you're wrong? Nobody knows, so who cares if you're wrong? You might be right. What goes into how far you go? When you take a trip, when you walk, when you ride, when you run? What?
Miles per hour.
Oh, what's part of that? Miles is distance, but what's the other? What is that unit?
Per like inch. And
Well, just the hours part. What is that? Hours measures what?
Time.
Time. Time is part of it. So if I want to know the formula for distance, part of it has to do with time. What else goes into distance? How long is time? What else? Yeah, how fast are you going? That's it. Distance is measured by two things and two things only. How fast are you going and how long are you taking to go? How long are you traveling for? And you multiply them together. So to give you an example, if you go 60 miles per hour and you travel 2 hours, how far did you go? 60 miles per hour and you go 2 hours, say it again.
120.
Yeah, you go 120 miles. Because you went 60 miles in the first hour and then 60 miles again in the second hour. Add them together, that's 120 miles. That's all that's involved in distance, speed and time. Now, your speed will typically go up and down. You're not going to go exactly 60 because you can have red lights and go through cities and do stuff like that. So you have to kind of say, well, what's my average speed? Just take your best guess at that. And then time is actually pretty consistent. That doesn't go up and down. Time is just how much time passes. So when you go to Google and you say, how long is it going to take me to get somewhere? That's all they're doing. They've got a complex math formula that's really just those two things. But there is one piece that is actually complex. Now here's the thing. When you go to Google, are you normally concerned about how far you're going? Like if you look up, you're going somewhere, are you normally concerned about how far it is? What are you normally trying to find out when you Google directions?
How long it takes.
You want to know how long it's going to take you, right? You don't really care about how far it is. You just want to know how long it's going to take you. Well, but that's not what the formula is. The formula is for finding the distance, right? But we want to know how long it's going to take me, right? So guess what we can do? We can solve for time. We're going to solve this equation, but we're going to solve it for time instead of for distance, which is what it's solved for right now. Distance is all by itself on one side. That's what we've solved for, or that's how the formula really comes. Let's solve for time. What do we do to solve for time? Why? See, it freaks you out. What do you mean? How do we solve for time? Yeah, you do the opposite math. If we want to solve for this, then we need to get rid of that. We do the opposite math. It means get the variable alone. This is the variable we're solving for. We want to get that all alone. So we just do the opposite math, just like we do if it was numbers there. If this was a number, and that was multiplied times a variable, we would divide by the number. Well, we're going to do the same thing, only we're dividing by another variable. I didn't write letters up there, but the word is representing the variable now. What's my number one rule? So if I'm dividing by speed over there to get time all by itself, then I better divide by speed on this side. And then, so time equals, so the formula for time would be the distance divided by the speed. That's what literal equations are. Only instead of words, you're going to have a bunch of letters. Sometimes you may have 5 or 6 letters in a formula that you start with, and you got to solve for one of the variables. I'll tell you real quick how Google works. Like when you say, hey, how long is it going to take me to get somewhere? They do the same thing. They know how far every place is. It's been mapped out by, well, I mean, it's been mapped out ever since we had maps, really. But they mapped it out differently as well, and they actually know all the distances to go anywhere. Then what they do for the speed, because they have to know the speed to figure out how long it's going to get you there, they take all of the users that are currently logged in and traveling the roads that you're about to travel, that you could go, because there's multiple options. They take all those users, they do the average speed for those users on all the different types of routes you could go, and then they just divide it out. And they say distance divided by speed. They may have 10 different ways you could go. Whichever one of those winds up being the shortest time is the one that they spit out as your route. So it's not based on speed limits. I actually just found this out last year. It's not based on speed limits for the roads, because as we know, a lot of people travel over the speed limit. So it's based on what people are actually traveling on those roads that you're about to travel. So if there's an accident, that's how they adjust. They see that people are slowed down and that their average speed is way down. So that's why the time goes way up, because this number is super, super low, which means this goes up. So I just found that out last year. I thought that was neat that they could actually use data based on who was on the road right then. Any questions on anything? So we'll get to literal equations probably next week. Just remember, you're just moving stuff around, just getting a variable along. Doesn't matter if they're numbers or whatever. You're just going to keep doing the opposite math stuff. All right, so here's what we're doing today. We are going to practice multi-step equations. I'm going to do a quick review of a couple of things. You should have your pink sheet out with the steps on it. I'm not going to go to that sheet, but pull it out. I think I just gave one to Kira. Somebody else, Izzy, did I give one to you? So you need one, and you also need the equations. And there might have been one other person that doesn't. If you don't have the pink sheet, okay, you might have missed that. Actually, you had it a couple of days, but you might have missed it. So if you want, why don't you go ahead and go to the restroom now. Replace, this is the new pass. So just put your phone in there and take the pass. We'll start that now, even though I really want you to see what I'm about to do, but it's not a bad time to go. Anybody else that does not have the pink sheet? And if you have the pink sheet, you should have the worksheet. We kind of gave those out. Everybody else has it? All right, so I want to review these two things real quick. I say real quick. I took longer than I wanted to last. You need to be able to identify these two types of equations. Two-step and three-step. Be careful though. As I said, be careful, because there are some kind of tricks that you got to be aware of. Here's your definition of a two-step equation. So write this down. If you haven't written this, you can write it on your pink sheet, write it in your notes, but you need to know when you're at this. You would have one term with a variable, so that term has a variable in it. One term that is just a constant on the same side. Doesn't matter if they're on the left or the right. I could have written this. I could have written 7 equals, actually, let's even really go. I could have written, I'm going to change the whole thing up now. 5 plus 2m. So again, I've changed the sides, but I still have one term with a variable and one constant. They happen to be on the right, but it doesn't matter which side they're on. And then on the other side, all by itself, you have just a constant, just a number with no variable. That is a two-step equation. Wake up. Now you gotta be back up. Come on, Money. Come on. Wake you, wakey. Come on, you gotta have these notes. You're covering a lot of stuff today. So again, two-step equation. Anything wrong up there? See anything weird? Goes against maybe what I was just saying? What is it? What am I waiting for somebody to point out? Somebody's pointed it out, but they're super quiet. Somebody that's louder pointed it out.
It's two variables on one side.
I said you gotta have one term with a variable and one constant. We don't have a constant on that side. So this is why this slide is labeled be careful. Just because you have two things on one side of the equation does not mean you're at a two-step equation. So be careful. Has to be one term with a variable, one term that's just a constant, so no variable. Then on the other side, just a constant. I could have also done something like this, where I had 4x. Actually, we're going to get to that in a second. So don't worry about that. So that is not a two-step equation. If you are not at a two-step equation yet, you got to go back up into your steps and figure out where you're at. We're going to get to it in a second, but you'd be at step 2 on the multi-step equations because you have like terms on the left side. So we'd have to combine the like terms first in that. We'd have to say, okay, well, 4x plus 3x is 7x. So now let's go over here. So what Mr. Gill calls a 3-step equation. So this is Mr. Gill's 3-step equations. Because there are other types of 3-step equations. You need a term with a variable and a constant on both sides. So we have a term with a variable and a constant, and again, term with a variable and a constant. Term with a variable and a constant, term with a variable and a constant on both sides. That is what I call a 3-step equation. The reason that 2-step and 3-step equations are important, I said, is because this is the only time that when you go to solve, you are writing anything underneath the equation. Like here, actually let's change colors. We say underneath plus 2 and then plus 2. Or here, we would say subtract 5, subtract 5. We don't do that in this one. We don't write anything underneath that because we can still combine the 4x and the 3x first. So that's why these 2 and 3-step equations are important. Here, we want to get rid of the 2x. So look at step 4 on your pink sheet. Step 4, if you look out to the left, you can actually do this in that problem. It says on step 4, get rid of the term with the variable on the right side of the equation. It tells you everything you need to know how to do. It tells you which side of the equation to start on. It even tells you what math to do. What's the math that it says to do? Step 4, what's it say to do? Yeah, it tells you you're going to add or subtract in that step. So if you can identify when you're there, it tells you what side to start on and what math to do. And it says what else besides add and subtract right after it. It reminds you, do the opposite, right? So if I know I'm starting on the right, I'll do the bottom one. If I know I'm starting on the right, if I know I need to add or subtract, and if I know I need to do the opposite, and it does also say get rid of the variable term, so you know you're starting with the variable term. That's when you're doing something underneath the equation. In the top one, we would do the opposite here, so subtract 2x. Then we got to subtract 2x over here, add 4y over here. That's the only time you ever do anything underneath an equation. Biggest mistake when we get to these harder equations is people start trying to do that step too early. They're not ready to do that step. They should be doing something like this, combining like terms, or maybe doing the distributive property, although normally people see that they need to do the distributive property. But way too often when people should be combining like terms, they try to do something underneath the equation, like especially this. They try to do something underneath it like that. Like here, I'll show you exactly what they do. So what's wrong with this one? Is this a 2-step, a 3-step, or something else down there? Is that 2-step, 3-step, or something else? I'm talking about this one right here. Is that 2-step, 3-step, or something else? It sure looks like this. Why is somebody saying something else? Who am I going to call? I'm going to call him Damani. Because Damani is clearly sleeping because normally her hand shoots up immediately every time. So I got to wake her up. So Damani, how is this in the blue box different from that one? Why isn't it a 3? I said this is a 3-step equation up here. Why isn't that a 3-step equation? Be more specific. Give me letters. Letters and numbers so I know which one you're talking about. So a three-step equation, again, I said one term with a variable, one constant on both sides. One term with a variable, one constant. Well, I do have one term with a variable and one constant on that side, but on this side I don't. Here, I have two variable terms, which are called what? There's something that those terms are called. It's what allows us to combine. These are the only kind of terms we can combine. Well, that's the number in front, which is what we're going to use to combine them. But what are the terms called? If they have the same letter, same exponent. Same letter, same exponent makes them what kind of terms? Starts with an L.
Like terms.
Like terms. So we are not ready to do anything underneath, but this is what I see all the time. I see this right here. Plus 4y and then plus 4y right there. That's how people try to combine it. Number one mistake I see when you have an equation like that. They because they understand they need to combine them. They see that they're wise, but they try to combine them like this. What's the problem with that? Besides the fact I just told you it's wrong. What's the biggest problem with that?
You gotta all subtract that one. Because you don't have nothing in front of you.
That might be right, but there's something else I'm trying to get to that I've made a really big deal about this year. I even used my name again on it.
Whenever you do the right side,
Say it again.
whenever you do the right side, you do the left. Or the
So
right side.
what is my number one rule?
Whenever you do the
Mr.
one
Gill.
side, you do the other.
Did I do that here?
No.
This is what I'm trying to prevent by making that my number one rule. If you ever try to do that, which somebody will, guaranteed, multiple people will, no doubt about it, because it kind of sort of makes sense. You see that they're like terms. You know we've done steps where we've added or subtracted a variable term underneath the equation before. So it kind of makes a little sense to do it. But if you remember that rule, whatever you do to one side, you have to do to the other side, that doesn't follow that rule. Because if you did this, you'd be wrong. No, if you did this, let's say you at least remembered that rule. This is still the wrong step, mind you, what I'm about to do. You should just say, well, 3y subtract 4y is negative 1y. That's what you should do, combine the like terms on one side. We'll get to that in a second. But let's say you did that, but you remembered the number one rule and you said, okay, well, if I do it on that side, I got to do it on this side over here. That's fine. You haven't broken the equation yet. It's gonna take you longer to solve it probably, but you're still fine. You'll get to the correct answer. Problem is now you got to come up here and you're gonna have to do the same thing again with that 3y and move it over separately. So you did two steps instead of really what could have kind of been one step. But that would work as long as you're doing the same thing on both sides of the equation. So now I'm going to come back and show you the way you should do this. You were still writing that down. I just said plus 4y on both sides. All right, so here's what we should do. We are not at a three-step equation. We don't have a constant and a variable on this right side. That means we've got to be able to combine something somewhere on one of the sides. We can't combine over here because we do have a variable term and a constant over here, but we can combine like terms, same letter. Or if they're just numbers, they're also like terms. So we would combine these first, and we get that. Now what am I at? Now what kind of equation am I? What kind of an equation is that? Am I at a two-step equation? What's a two-step equation made up of? Who am I going to call him? Alex. What's a two-step equation made up of? Well, that's just what a term has. A term has a coefficient and a variable. So what's a two-step equation have in it? We literally just went over it. Should have written it down. Write this down if you don't have it down. I'm going to go with Jaden first. What's a two-step equation have that I just said? I'm going to make you all go back and write it, apparently. Didn't write it down. This is the problem with quizzes right here. You're going to see this on a quiz. I'm going to just ask you to identify. I'm going to say, pick out the two-step equations. If you don't have notes, you might struggle because apparently we don't know when we're at one. Or not at one. Who might have written it down? Izzy, did you write it down? No. Ryan, did you write it down? You're pretty good about writing something down. No. Aiden? All right, everybody write it down. We're not at one, by the way. So, write this down. A two-step equation. This is the only type of two-step equation, by the way. There's no, I guess theoretically there is another one you could say has two steps, but it's very rare you would see it. And it's really, I don't think anybody would call that a two-step equation. There are a bunch of different types of three steps. That's why I say that's Mr. Gill's three-step equation over there. But two-step equations, term with a variable and a constant on one side, and then just a constant on the other side. Now I'll spell constant out if you don't know how to spell it. If you don't know how to spell variable, I thought it was up there, but apparently not. So again, doesn't matter which side, because I flipped it around here. This is still a two-step equation, term with a variable and a constant on one side, and then just a constant on the other side. So all two-step equations have that. On one of the sides, a term with a variable and a constant. On the other side, just a constant, no variable term. So if you see variables on both sides, you're never at a two-step equation. I'd make that note also. Like underneath that, say if there are variables on both sides, you can't be at a two-step equation.
On the other side is just a constant?
Constant, this word right here, constant. Meaning just a number, there's no variable term. There's no variable on that other side. Which is why I just followed up with, if you see variables on both sides, you can't be at a two-step equation. It's not possible. Hold on just a second until we get through this, at least this part.
Oh, what else did you say, right?
So I said, if you see variables on both sides, you cannot be at a two-step equation. Because by definition, one side doesn't have any variables in a two-step equation. If you see variables on both sides of the equation, you cannot be at a two-step equation. So what's the problem then with this one down here in the green? That two-step equation.
Yes.
What did I just say? What was the last thing I just said? If there's variables on both sides. So again, I'm going to repeat it again. You better write this stuff down because this is what winds up happening. When I've gone over it this many times, this is the kind of stuff that appears on your quizzes. If you see variables on both sides of the equation, it cannot be a two-step equation. It could be a three-step, might be a three-step, but it cannot be a two-step equation. Because by definition, a two-step equation only has a constant on one side, just a number. So this cannot be a two-step equation because I have variables on both sides. Now, this is kind of an exception. The odds of you running into this are pretty slim, especially on something I make up, but it could happen on a worksheet where you get something like this. You have to realize that is not a two-step equation. You don't solve that by starting with the constant. We still have to get all the variables to one side. So we're kind of at step 4. Technically, the way this equation would read, if you want to consider it a three-step equation, it'd really be plus 0 out there. Hold on just a second. If you're waiting for the restroom, you're going to be in line after this. So that now would make it a three-step equation. I have a term with a variable and a constant, a term with a variable and a constant. So that's really the way that you would think of that equation if you wanted to say, well, that's a three-step equation. Again, and the reason those are important is that's the only time you're ever going to add or subtract underneath. So here's what I want you to do. Oh, get your worksheet out. This has the first problem is 4n subtract 2n equals 4. Get that out. We're going to do a couple of them that are just combining like terms problems. Then I'm going to do an example of one of the distributive property ones, and then you'll work on the distributive property ones. Oh, your bell or your exit ticket this week. I'm going to do something a little different than what we've done. I tried it in my big class. It didn't work as well. There were just too many people in it, but I think it'll be fine for this class. I'm going to give you one extremely long equation. So instead of giving you a bunch of equations, and some easy ones, some hard ones, I'm just going to give you one big equation. Something that's going to look like these. When I say it's going to be long and difficult, it's going to be long and difficult, like these. You have a lot of stuff going on. But you get points every time you do something right. So you can build your way into a decent grade even if you don't know how to solve it all the way out, or if you make some mistakes. And you can keep trying. Like, if I check it, you're not just going to do it and turn it in. You're going to do it. I'm going to say, oh, nope, you need to look at step 3 or step 4, or look at this, or look at that. Then you get to work on it again. So you have multiple tries at it. The harder you work, the more points you're going to get. If you get it all right on the first chance, you got 100, you're done. I'm going to do an example of one of these in a minute. First, though, let's go back up to some of the easier ones where we're really just, there's no distributive property yet. I think I already did one of these. I'm going to do the same one again. I am going to go ahead and do this one because it's dumb. I don't like it. On number 4, although it does trip people up all the time, do we have any distributive? Let's use our sheet, by the way. Do we have the distributive property in number 4?
I don't got that sheet.
You're looking at it. Oh, you're done with the problem here. All right, so again, you guys have got to bring this stuff back with you. I mean, we worked on it 2 days. If you were here, and if you have the pink sheet, you have this sheet. We worked on it on the same days. So I don't always have extras. Luckily, because I haven't enforced this a lot yet, I made a bunch of extras this time. Eventually, I'll say, no, you can copy every single problem down by hand. So bring it back. If you're having trouble bringing stuff back, leave it in the room. That's why I have the baskets over there. You have a folder that is just for math, leave it. You don't need it. None of you are going home and practicing. If you are, fantastic, but I doubt very seriously I got anybody doing that. If you take it home the night before a quiz, be careful, because if you do actually use it and you forget to bring it back in, you're still taking the quiz. I'm not going to forgive you because you forgot your folder. I mean, forgive you meaning I'm not going to let you out of the quiz. You've got to take the quiz. So don't forget it. If you take it home, you're taking a chance. I'm not sure if you're hiding it from me or from yourself. So keep it in here, because eventually it's going to cost you. You're either going to not have something that you need to have, or you're going to have to hand write everything if you keep losing these sheets. So do we have distributed property? Once again, how do we know if we have it? Who am I going to ask this time? Landon, how do we know if we have the distributive property? What are we looking for? Where's your pink sheet? Daniel. Do we have any parentheses? It even tells you that on the pink sheet. If you look to the left of number 1, it says look for parentheses. So you don't have to remember that. Even if I say it's not an open note quiz, I will always let you use the pink sheet. I will never make you remember the steps to a big multi-step equation. So I may say that's all you can have out, but I'll never say you can't use the pink sheet. So if you don't have one, like if you lose it, make sure you get one. So I don't have any distributive property. What's the next step? Aiding. Other aiding. What's the next step? Unfink sheet. More to it. Well, not left or right side. So I want to specifically do just 2. If you did not underline this, like if I just gave you the sheet, I'm just saying, you need to underline in number 2 where it says on the left side. So those of you that just got that today, just one maybe, you need to underline on the left side. Then in number 3, you might as well go ahead and underline on the right side. When we do this, we don't look at across sides. Like I'm not trying to combine, that's not a good example. I'm not trying to combine this 4K with this 4K over on the right. I'm only looking at the left side, doing everything I can on the left. Then I'll ignore the left and I'll only look at the right. So that's why I had you underline that. So if I'm only looking at the left, do I have like terms on the left? Leo. That's what. Leo. 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 There he is. Leo. Wakey, wakey. Oh my goodness, he's out. I'm asking you a question, but you are so out of it. I'm still going to ask it to you. But do I have like terms on the left side in this equation? Do I have any like terms on the left? You can't see it. You should have the sheet. Those are like terms. Remember, if you have the same letter, we said for a while, we're going to always have the same exponent. So anytime you see the same letter, those are like terms. And we're only looking at the left side, which we don't have any over on the right side anyway. But so yes, I have like terms. If I want to combine those, I say 4n subtract 2n. It's just 2n. Say restroom. Oh, you don't have the worksheet either? Holy cow. Let me finish this one and then I'll let people start going. I think, did you go yet, Jasmine? You're still waiting. Oh, you did? I did let you go. All right, so I'm only going to do this one time really quickly because a lot of you are still struggling to combine positive and negatives. If I need to combine like terms, think of it as money, dollar bills specifically. If you have negative $7, what would that mean? You owe is the word. Debt is good too, if you know what that means, but I'm going to say owe. If you have a negative number, you are owing, if that's what you're starting with, you owe money. You owe somebody 7. If somebody then gives you $3, that's what plus 3n would be in this case. The variable is always going to be dollars. So negative $7 means you owe $7. Somebody then gives you $3, you can pay some of your debt off, but you'd still be in debt. You would owe now $4. Don't forget the variable. Now, let's take another example. Let's say you start with positive money. 4n, but let's say you have subtract 6n. So you have $4 this time, that's a positive 4n. But somebody comes up and they're being a bully and they say, hey, give me, I'm going to take from you $6. That's what subtraction would be, taking from you. They're telling you to give them. So you can't give them 6, so you have to owe them, well, you owe them 2, because you can give them 4. So you give them 4, but then you're like, that's all I've got. They're like, okay, well, then you still owe me 2. And again, owing means negative numbers. Then the last one that you could possibly see, let's say you owe somebody $5, so you're negative 5n, and then they come back to you and they say, give me 5 more. You're like, okay, well, I don't have any money. I already owe you 5. I don't have any to give you. They say, okay, well then instead of just owing me 5, you now owe me 10. You owe me 5 more because you're negative 5, and I'm going to take from you 5 more. That's the biggest one that messes people up. When you start with a negative and then you subtract a number from that, you have to think about that as you already owe them Now they're taking even more from you, so you're more negative. You owe them more money. So it's a bigger negative number. So those are kind of the three tougher examples, like 4n subtract 2n, you just basically it's 4 subtract 2. So I'm not going to spend a whole bunch of time on that. All right, so I want you to, oh, and then here, I'll just finish it out. We skip over a two-step equation there, and we just go straight to the last step, which is doing the opposite. If that's 2 times n, we divide by 2, n equals 2 for the first problem. We have the first one done. I want you to start working on those. You got about 30 minutes probably. Should be able to get a few of these done. So I'm going to be walking around. Some of you I'm going to pretty much leave alone. So if you're asking me questions, I'm probably going to be working with other people, so just do your best. We're going to be doing this again on Thursday. If you want to skip straight to the harder ones, because that's what you're really going to get quizzed on Thursday, you can do that, that's fine. If you're not ready for that though, then you need to work on the ones that are combining like terms. Maybe you could start working on the ones that start the distributive property. So are you next? Who was after you, remember? What was the order of the restroom? Izzy was next.
Then someone than me.
And someone then me. Nobody's saying, it might just be you if nobody's saying, maybe it's one of the sleepy people. Well, I don't think either of them has. Were you waiting? Okay, so neither so much. So you can go, Izzy, replace that with your, the pass with your phone. Whoa, whoa, whoa. You got to take pass though. Over your eyeball. We got a new pass probably since you were here, the green thing. Yeah, you're after Nadia. If we have time, which we should, we got 30 minutes. A little more than 30 minutes. 49, yeah. All right, so again, when I get to you, if you're struggling, you better have your sheet out in front of you, trying to figure out what step you would be on. I don't care where you start. You want to start with the super hard ones, you can start with the super hard ones. Your grade mainly is based on you doing something today. As long as you're doing something, you'll be fine. And then I just need to see who I need to work with for the quiz on Thursday. Question? Oh my goodness gracious, I said this like 6 times at the beginning of class. That's 3 or 4 people that are just messing at it on which. And you were here. Look. You didn't miss it. If you have that, you should have this. Look and see, because we did some problems already. So look first. If you don't have it, I'll come back here so you know. We used the pink sheet to do the, see, and I'm almost out of pink sheets now. I probably won't have, oh, I could probably copy it after. As long as they have enough. All right, I'm going to give you a couple minutes before I start walking around. I may, if you've got some done, I may ask you a couple of questions, and then I'll probably just move on if it looks like you're okay. I'm mostly concerned about some of the people that were struggling still with the two-step equations. Yeah, that's that one. I mean, if you have questions, I'll still answer questions, but I'm just going to give everybody a chance to get a question. Or? Did you find it, Leo? First problem is the 4n subtract 2n equals 4. Yeah. If you have the pink sheet, we used on the same days. Yeah. Oh, I am going to stop you all, like even after I walk around for a minute, because I do have to show you an example of the distributive property. basically one of the tougher problems. Wakey. I'm working. Working. Wakey. So I already did that. How you doing? That one, work your way through. Whoa! Holy cowabunga, right in the front row. Bold. I did see it, so why don't we put that back? Because I can tell something's going on, and you're all excited about what's going on in that little Snapchat conversation that's going on, whatever it is. They call it conversation? Red?
Yeah. Well, when you're left on red,
That's called chat. Oh, well, you can tell them, Mr. Gill said I got to go. I'll tell them that. You give them my Snapchat, and I'll tell them. What? Yo. You got Snapchat? That's weird. Why is that be weird? I don't know. Some teachers use it to like, because that's about the only thing you guys pay attention to is Snapchat. So
You're over 18. I don't think you should have Snapchat.
So you're gonna stop Snapchat when you turn 18.
No, it's not later to be called.
Is that what it is? Yeah, I just do Facebook, so you don't have to worry. And YouTube.
Facebook
That's
kind
all
of
for
like
you guys.
Facebook's like 40 plus.
Oh, so what should I do then?
Yeah, it's like 40 plus.
So what's the in between then? What should I
There's
do?
no in between.
So like, there's nothing for anybody in.
I don't like. Okay,
There's nothing
but, like,
besides. So
Facebook
like,
is
you
like
just
for, like,
can't do any
it's like
media.
Facebook's for like users, like old people.
But what about like, what
It's
if
like
you're,
your
what if
auntie
you
trying to,
can
like,
use
put something
Snapchat?
on.
But what if you're over 25 and you can't use
Instagram.
Snapchat?
You can like use IG.
And
like,
then, oh, Instagram. All right. Well, I do have Instagram also. I don't really use any of it. I don't do any of it. I used to when I had a job where I needed to like do a lot of networking and I needed to know a lot of people. I used to use social media then, but I don't need to do that. Yeah, I rarely use any of them anymore. Some of my friends are still on both of those, so sometimes I'll communicate with them. Geezers are on Facebook. I'm telling all my friends. Like, yeah, that's what Izzy said. I can't wait till you're on Facebook and be like,
Facebook's like old aunties. That's
Auntie?
gossiping.
auntie?
That's yeah.
Do you say auntie or do you say aunt?
Aunties?
You say auntie?
Yeah, they just be gossiping. Like,
Yeah.
hello, baby mom.
Facebook Lives.
I do use Facebook Messenger for one of my buddies because he travels around the country and he's always on his computer. So he's rarely has his phone next to him, but he's always on his computer. So we use Facebook Messenger to talk a lot.
You have Jordan Facebook Lives.
I don't use any of it. He's the only person I really use that for. I'm not on. Occasionally I'll go on there and see what like friends that I know are up to. But rarely. I don't have time. Too much other stuff. Oh, Daniel, why don't you come on up? What place were you in? You were in third place. Hold up. You don't want anything? You don't even know what's in there. Nothing. There's pencils and stuff too. That's funny. If he looks though, he might decide he wants something. Nothing? All right. You have a question? Yeah, let me, Ryan, did you come up already?
I don't want that.
You don't want anything. You don't even know what's in there. Alright, it's not just candy.
Oh, can I take this?
There's like pencils and stuff like that in there. There's pencils, there's... No, he won't, well, I mean, if he wants to come up and get it, he can give it to you, but you can't have it. Oh man, look at that. I can't believe you guys don't want anything. What if I had like a really cool thing in here, like a fidget spinner? I don't know, whatever's cool, I couldn't throw it in. I have pencils. What if I had a pencil sharpener?
What the?
You might want your own pencil sharpener. Yeah, all I have is pencils. I thought I had some other. Oh, somebody took the other thing that I had. Sometimes I put like stuff in there that I don't want anymore, and I put it in there. Like, you know, something I bought and I never gave away to somebody.
iPod.
Like for kids, I used to buy all kind of stuff for It wasn't that good, but it wasn't cheap, like relative to candy. Somebody already took it.
Yes.
With the nurse, you need to get something done. You need to get something done. That's why you use that sheet, and you follow the steps. Oh, right. Walk me through one. Which one are you on? All right. So, well, we don't. But do you? What does it say to the left of distributive property? Huh? To the left of the distributive property. To the left of step 1. What does it say on your page?
2/x plus
No.
That's the right.
2/x.
To the left. Do you have any parentheses? Then you skip that step. The only time you do the distributive property is when it looks like that. So do you have any like terms on the left side only? So left of the equal sign. Do you have any like terms on the left side of the equal sign?
No.
You don't, right? You only have one number then, right?
Yeah.
Okay, so we're past that step. So now we're on step 3. What's step 3 say?
Combine like two. We skip that since I don't have any. Get rid of
Well,
that.
what's step 3 say?
It says combine the like terms.
Specifically, keep reading.
Combine
right
the
side.
like terms on the right side of the equation. Yeah, I got some.
Oh, now we have some like terms on the right side. So which ones are the like terms?
5b and 2b.
So what do we do?
We add them.
Yeah. So what's that?
So 7.
So step 7b.
7b.
Now what kind of an equation are you have?
Now, 2-step equation.
You should know how to do those. You were here when we were doing those.
Aha.
What's the first step? Now you go back to the top of the sheet where it says 2-step equation. No, top. You're in the middle.
Start with the constant, then the same side of the variable with the opposite mass.
So you should have a new equation that looks like this. You should have that equation now, once you combine the 5b and the 2b. That is a 2-step equation. Which side is the variable on? What's a variable? Which one of those is a variable in that equation? What do we use to represent a variable?
And the other bits.
Well, a symbol, but normally we use what? Like what symbol do we use? He's just saying something. What do we use to represent a variable? We don't know it.
A symbol.
What symbol though do we normally use? A letter, right? We normally use a letter. Where's the letter?
G.
Where is it? What side?
Right.
Right, that's what I wanted you to say. So, let me get rid of this. So it says start on the side where the variable is, right?
Yeah.
So we're going to start on the right. Which one of those is a constant on the right side?
Constant.
No, you tell me. Write on your pink. If you ever have to ask me, you got to write on your pink sheet. You don't know. So what is a constant? You guys, instead of like being annoying, be useful. What's a constant? What's a constant?
Well, like it.
You should know constant. We've been doing that for 3 weeks. What's a constant? Should know it off the top of your head.
The opposite.
Not opposite. That's when you're doing the steps. We do the opposite. A constant. Well, we're saying what it. We're first of all we got to identify what a constant is. That's what we're trying to do first. What's a constant?
Strong binary.
Alani, what's a constant? Did you hear, Izzy? Say it again. So it's the number that doesn't have a variable. Which number doesn't have a variable with it on the right?
12 and 2.
But on the right, we already said we need to start on the side where the variable is.
So
So
on the right, none.
yeah, there is.
You
said it. 2. This doesn't have a variable with it, right? That's the no. This is a constant. You were right. So Izzy, you were right. This is a constant, but it's not on the side with the variable. The only constant on the side with the variable is that 2. That's where we start. So now, what's it say in step? So we now know where we're starting. And then what's it say to do with that constant? No, you're back. We moved up to the top, remember? We moved up to the top of the sheet.
Probably dead.
Take that.
Two-step equations are up here.
Do the opposite math 2 times.
Okay, so what is so if we're starting with that 2, is that a positive or negative 2?
Positive.
Positive 2, right? So what do we need to do to get rid of that positive 2? What's the opposite of that?
There you go.
So if that's positive 2, these signs should always be the opposite. The sign of the number in the equation should be the opposite of the sign of the number that we're using to get rid of the number. That's what makes them go away, is the opposite sign. But what's the most important rule according to Mr. Gill? Really? Man, it's the most important rule and you don't know it. That's gonna be trouble.
So whatever you do on the right side, for the left side.
Well, whatever you do on one side, or really it's your first side, whatever I do on my first side, I have to do the exact same thing on the other side. So that's your first total step to solving that two-step equation. So what do I have left? Now, what's my next line I need to write?
We're down to 7.
So we didn't do anything with that, so we got to bring that down on the right. And I see that you're paying attention, so if you need anything, Jasmine, let me know, but I think you're following along. So what do I need to bring down on the left? What's the math on the left? This is that one where I said we have 2 negatives involved. It is actually. What's the math on the left then? What am I writing on the left?
Negative 13 equals 7.
Perfect. So what, Izzy? What do I write down on the left? What's on the left? We brought the 7v down, but we got to put something on the left.
Negative 10.
What does it represent if you have negative 12? If I say we're talking about money and you're negative 12.
You owe $12.
So, and then I come and I say, give me 2 more. I'm taking 2 more away from you.
Negative 14. You're in debt 14.
It's negative 14, not negative 10. So you got to be careful with that. If you're negative and then I take more from you, you become more negative. You owe even more. So that's negative 14. Now, my last step, I do the opposite math again. What does 7v mean? Well, that's what we would do, but what does 7v mean? What's the math? Well, what's the math going on between the 7 and the v? Yeah, that's multiplying. If you have a number, again, all these things, if you don't know them, you better be writing notes to yourself about them. Because if I have to explain all this stuff over again, I'm going to walk on. I'm not going to explain. You haven't written a single note about anything I've said. So I'm hoping you're absorbing, and I'm fine if you don't write it down, but you remember it. That, a number next to a variable means multiplication. So if that is being multiplied, I need to do the opposite math, just like it says on the sheet, do the opposite math. Well, the opposite of multiplying by 7 is dividing by 7, and if I do it on one side, I've got to do it on the other side.
14 divided by 2.
And then now if you divide that out, you get negative 2. So v equals negative 2 for number 2. So you can try to do, number 4 is super easy. You're just basically taking 3, subtract 3, and then x equals negative 6, so don't worry about that one. Try to do number 3. All right, so while I was helping them, who else needs help? Oh, I got to show a distributed property. So negative 3x. Yeah, you kind of moved stuff. Here, I'm going to go ahead and do distributed property now, and then you can try to do that one again. Is that an erasable pen?
Look, he said it.
Is that a erasable pen? Oh. All right, use pencil for in here, bud. All right, so I know Miss. Oh, let me help anybody that needs help real quick. Or was this not bad? Let me do this first. All right, so now some of you have hopefully been working on the other ones. I do want to show you the toughest one you're going to ever see. Well, I shouldn't say ever. Look at number. Which one did I do in the other class? 15 is pretty good. I was going to do 15 or 17, so 15 is pretty good. I'll have to kind of write over 17, but that's fine. So here's what I am teaching it this way. If you understand how to do this and you don't make any errors, you can do it however you want. But what's the hardest part of the distributive? So the distributive property is when we have parentheses. What's the hardest part of that, you think?
Is figuring out which parentheses you should do first.
But it doesn't really matter which one you do first. That's not really an issue. I could do this one on the left first or the one on the right first because they're not like combined. Like I'm just gonna do it's like kind of like I'm just doing them both separately. I am doing them separately. Anybody have any idea what looks so tough about those distributive property problems? What's easier? What's the easier distributive property? This or this? Which one? Left or right? What's easier?
Left.
You think the left one's easier? Right.
Right.
Why would you say right's easier?
Because, I used to like,
Do you have to know any rules about multiplication using like negatives in the right one?
no.
There's no negative, right? You don't have to know any rules. Everything's going to be positive. Here, you have to understand how to use negative rules of multiplication. Negative times a negative, negative times a positive. What's the end result? That's what messes most people up with distributive property. So I'm going to show you how I do this. And in the process, I'm just going to remind you of how to do the distributive property in general. So here's what I do. I just make every number positive or negative. I don't worry at all about addition or subtraction. I'm never going to write an addition sign or a subtraction sign when I do the actual distributive property. So on the left side, zoom in, there we go. On the left side, I could actually do some stuff here. I'm not going to. I'm going to take it really slow since we're still kind of learning this. And I'm just going to rewrite that for now. So here's what I'm going to tell you I think is an easy way to do it. I mean, this is a hard problem, first of all. So if you're freaking out, that's fine. I think this is the best way to try to unclutter it. Every number is either positive or negative. Don't ever put addition or subtraction until you do the math. So is that a positive or negative 2? On the outside of the parentheses. Yeah, there's a negative in front of it. Whatever is in front of the number is the sign of the number. So if there's a negative in front of the number, that's a negative 2. I'm then going to multiply that negative 2 times both of these that are in parentheses. So by the 2p and the 4. So I multiply it. Well, I'm not going to do the result yet. Is that a positive 2p or a negative 2p? So I write positive 2p. Again, I'm not then going to write any addition or subtraction. I'm just going to write the sign of the number again. So I got to use the negative 2 again because I got to multiply it now times the 4. So that's a negative 2. And again, times positive 4. I didn't write any addition or subtraction in between them because it'll just work itself out, as you'll see in a second. So now, so now I'm on to the next distributive property. I have to do distributive property twice in this because there's 2 sets of parentheses. Is that a negative 3 or a positive 3? Yeah, if there's a negative sign or a subtraction sign in front of it, it is a negative 3. So again, I don't write plus or minus, I just write negative 3. And then I'm multiplying that times both of those. Is that a positive 2p or a negative 2p? Positive, right? There's nothing in front of it, so that's times positive 2p. And again, so I'm going to use the negative 3 again. So I would write negative 3 times, is that a positive 2 or a negative 2 at the very end? Negative, right? Whatever's in front of it is the sign that I use. Now I just do the math. Now you do have to know the rules behind multiplying, but there's only really 2 rules. If you have one negative and one positive, when you multiply, it's a negative. Doesn't matter which one's positive or negative. Like, it's kind of the same. Like I could change the order and say 4 times negative 2, that's still a negative number. So if you have one negative, when you multiply, it's going to be a negative. So again, I only have one negative here, so that's going to be negative 4p. What's the next one? Who am I calling? Jeremy. I've been calling you. I think you've answered some. What's the next number? Negative 2 times positive 4. Yeah, negative times a positive is a negative. So here's what I do now. I write the negative, but I'm actually going to write now like that. So it pretty much becomes subtraction. The addition or subtraction will take care of itself when you just do the math. So now, I've taken care of those first two. Now I come over to this one. Negative 3 times positive 2p. Is that a positive or a negative? It's a negative, right? We said a positive times a negative is a negative. So it's negative. Don't forget the variable, by the way. When you multiply the two numbers, you got to also keep the variable in there if there's a variable in there. Variables can never just disappear. Sometimes you guys forget about them. Is that negative 3 times negative 2? What is that? I'm going to go with Luna. What's negative 3 times negative 2? Is a negative times a negative a positive or a negative? I can't hear you if you said it. Just say it loud, Greg, if you know it.
Positive.
Yeah, a negative times a negative is a positive. So if you have two negatives and you multiply or divide, it becomes a positive. That only applies to multiplication and division, not addition. Too many of you try to use it for addition also. So that is a positive 6. When I write positive 6, that just becomes plus 6. So if you do it that way, I feel like that's the easiest way to not make mistakes. If you have another way to come up with that, I don't care how you do it, as long as you're getting the right answer. So that is now your new right side of the equation. This is still your left side. We didn't do anything over here. Now, you're done with step 1. You can move to combining like terms, and you should have an idea of how to do that. So I'm going to let you finish it from there when you get to it. So at least have that much. You don't have to finish this one right now if you want to do some of the other ones up top, but you should at least have an example of how to do the distributive property. So if you want to do some of the ones with the distributive property in them that are shorter, you can do that too.
So this is the answer.
No, there's more. You got to keep going. Because now you'd be on step 2. You have like terms on the left, right? So you'd have to combine like terms on the left. Then once you were done with all the like terms on the left, you got to combine. This is something like what your problem is going to be for your exit ticket on Thursday. So you'll do, let's say you just do this first step. I'll come over, I'll check it, and I'll say, yep, you're good. Go to the next step. Or I'll say, no, you need to look at this distributive property, the 3 and the 2, or something like that. And you'll look, I'll give you hints on what you need to look at. But everybody should wind up getting a good grade on that. Because you're going to be able to keep working on it until the end of the class, and I'll tell you what you need to look at to be correct. I'm not going to tell you exactly what to do, but I'll tell you where you need to go. What you doing, bud? Not even close. You get like 8 minutes. So keep working. I'm going to keep walking around. I want to see, who have you worked with, Ms. Thompson? Do you know? Just
see. I'm trying to work with him. I've worked with Landon.
Oh, Kira, you had a question I know earlier, so I'll start with you. Oh, okay, good. So you're good? Yes. Well, here, I want to see you start from scratch.
Answers and not work.
Right, just do that. So just do a shorter one with distributive property first, and then I'll come back. You either do this one, or you want to skip the one with the distributive property. All right, start on 5. You have distributive property in 5? First step. Use your sheet. Sheet walks you through it. You have the distributive property.
Yeah, I'm seeing several people with their each sheets
now,
out, which is good.
Combine like
This
terms on
is
the left.
what you need to go back to and look. Good
So we
job.
have like terms on the left side of the equation. How do we know if we have like terms? That's a two-step equation. How do we know? Okay, we're not there yet. That's here. Like terms. It says to combine like terms. How do you know? Same letters. We have the same letter, or it could just be numbers on the left side. We shouldn't be packing up yet. Dejan, you definitely shouldn't be packing up. You didn't do anything. So keep it out. I'm protecting you now. We'll put in this one. We do on the left? No, we have one right.
Okay, so what are you gonna
We
distribute?
can combine those terms. How
Got
would
all
you
that
combine negative 2
4
base
R is, got all
If you owe me $2, it'd be negative 2K. Dollars is always when you have a variable, it would be any variable on
Now you're gonna.
So you owe me $2. And then I come to you and I say, give me $3 more. How much do you owe me now?
So is that gonna be positive or negative?
Because you owe me 5. Owing means
You
you're
have two
negative.
negatives.
So
Oh,
negative
multiply
5.
by
So now you're,
plus.
once you do that, now you're the
It's
2.
gonna be a plus, not a times. Plus. Equals.
Very good. Yep. Yes.
And then I recommend that
So this is positive for B.
like I said, I like it too, is when you talk about that.
You have $4 and I take try to take 6 from you.
Jump it and do it to the other side.
I
Right,
want
so
you-
what are you gonna do first?
Hold on just a second.
Yes, there's
Negative,
nothing
okay.
else I can
So
do.
when you,
So move it to the other side, get rid of it on this side.
So I was at negative 24.
Minus 24, yeah? If you better do it on both sides.
so when you do the distributive property, you are taking.
Okay, so bring down the line here. Yeah. Yeah, exactly. So what do you have left here? It is 12 R.
This number.
You
right
got all
here.
this. If it's a negative
Times X, and
39,
again.
what? You gotta add that. Is it gonna be negative?
And I'm not gonna write plus or minus.
Those things we do. Snapchats.
Yeah.
Okay, negative times positive.
For the second time.
So this would be negative.
So now what's attached to R? Okay, how do I get rid of that 12?
That is negative 6.
Divide by
Yeah, negative. It's a negative 12. I got slack. When you divide and multiply, you drop that negative.
Drop the R.
Then, oh, and then we always
Get rid
put
of the
2-step
12.
equation.
That's gonna be R by.
So now we're in a 2-step equation.
Exactly.
Oh, we're showing the variable. We always start on the side of the variable. We would actually start on this side. Oh, wait, I'm sorry. I'm not sure, I'll be honest.
Okay, and then what do I have here?
This is where you would be if this is what you would solve out. So try to solve that out
That's a
there.
variable.
And
That's
then I
what you
want
want.
you to try to do one
There you
of
go.
those.
You got it.
May not get through with it, but at least you distribute it properly and at least set it up where you get it to your First, try to solve
I'm
that.
gonna head out for the bell rings.
Got it.
All right.
I will, see, I think I'll see you next week.
What in
Six.
the world are you doing?
6.
And just write the number down. You have work that you did in your notebook or you just wrote it down?
Of course.
You gotta write on here though. I can't. Oh, the other day, you're saying, okay, well, let's try I want you to try that one again. I'm not gonna make you do all of those, and I see what you're saying. So try that one. I do remember that you were working on it. But try that one again, so you can do it fresh.
Fresh.
Negative 12R plus 24, good. That's tricky right there. 6. Right. Good. Fantastic. That's perfect.
right there. But still, I don't need.
Well, what's this again?
Then you open your position.
Oh, not reading that? Where are you at? So it's two equations. Or maybe I should tell you. And the constant on which side? Well, the side with a variable, which in this case is correct. So what do you do with that constant?
See, Sean's been into this guy since like very.
What's the opposite? Well, always gonna do for the first step. You're gonna either have first step. So what's the opposite of those?
I gave it a
Matters to
Yeah,
grade.
Yes.
So it's either positive or negative.
You ain't done it since. It's a little low.
It's like the opposite isn't
They go
right.
around.
If it's a positive, you have to make sure the signs are signs themselves the opposite.
Oh, that's KP.
Yeah, exactly. 'Cause we want to get rid of that 3. We want the whole All right, so we'll pretty much just start working on this Thursday before your exit ticket. You say, like, let's let it go. You still got another minute. 4 was, are you asking what the answer was? 4 was the easy one, like x is negative 6. Oh, what'd you say? What was
You
it?
told me to change the 14, you said change it to positive, but it said, come on, Griffin, let's
Oh,
go.
no, I said you have.
Griffin,
Wait,
let's
it
go.
said negative? All right, we'll look at it again on Thursday.
Did the funding machine give you cash back?
I have no idea. Maybe up to a point, but like if you got a big bill, probably
I have
not.
$5.
That, I don't know, maybe, possibly, I don't know.
Because I read on the thing, it said it takes 1 to 5, but I don't know if it takes anyway.
Again, you're running and even if it does take 5s, you're counting on there being enough change in there for it to give you change back. So that's, depends on how bold you are, how brave you are on that.